Hi, I'm Patty. I'm going to lead you through this unit orientation video for the kindergarten unit, Pushes and Pulls. In Pushes and Pulls, students take on the role of pinball engineers as they figure out the anchor phenomena in their unit. They work to help investigate the effects of forces on the motion of an object. They will be testing their own prototypes or models of a pinball machine and using what they learn to contribute to the design of a class pinball machine. Over the course of the unit, students construct a foundational understanding of why things move in different ways. Students analyze motion and the forces that start motion, change the direction of motion, or stop motion. They do this to determine how to make a pinball start to move, go different distances or directions, and to different places. They learn that engineers construct solutions that do what they want them to do. Students work throughout the unit to design a solution and create a pinball machine that lets them control the way a pinball moves. As they work through the 6 chapters in this unit, they gather evidence from multiple sources by doing, talking, reading, writing, and visualizing. Their explanations become more complex over time as they construct scientific explanations that describe that the different ways that an object moves are caused by different forces exerted on the object. In particular, students will focus on investigating and explaining the different distances and directions that a pinball can be made to move in a pinball machine. This unit is a design unit. In their role of pinball engineers, students develop skills with the science and engineering practice, constructing explanations and designing solutions, with a particular focus on investigating how forces affect motion and analyzing data from those investigations. Students use data from their observations to help design a pinball machine where they can control the motion of the ball. The focal cross-cutting concept in this unit is cause and effect, and students have chances throughout the unit to consider how forces influence motion, helping the pinball start moving, change direction, and stop moving. Every Amplify Science elementary unit also includes a focal sense-making strategy, which students leverage as they read and also during investigations. This unit's sense-making strategy is visualizing. Like most units in Amplify Science, K5, the main writing genre is explanation. That's the overview. Now I'll talk you through what happens throughout the unit, how students build from their prior knowledge to get to a complex causal explanation of the anchor phenomena. To do this, I'll summarize the key ideas students figure out in each chapter and how they use these ideas to explain the anchor phenomenon piece by piece. For each chapter, I'll highlight 1 or 2 key evidence sources students use. But remember, in every chapter, and indeed every lesson, students gather evidence multimodally from many different sources. In Chapter 1, students learn that an object starts moving when a force is exerted on it. If an unmoving object starts to move, that's evidence of a force acting on the object. One key evidence source is the investigation where students look at how to make an object move by exerting a force on it, and then they explain forces and movement observations from the investigation using explanation language frames. At the end of Chapter 1, students return to the anchor phenomenon. They explain that to make a pinball move, a force must be exerted on the pinball. They have learned that they can use a rubber band launcher to exert a force on the pinball. In Chapter 2, students focus on understanding that a stronger force causes an object to move a longer distance, while a gentle force will cause the object to move a shorter distance. Key evidence sources in this chapter include an investigation into how to make a tennis ball move long and short distances, a reading about forces in ball games, and a shared writing about modifications to the pinball machine. At the end of Chapter 2, students are able to explain that to make the pinball go the distance we want, the rubber band launcher has to exert a strong force. To make it go a shorter distance, the launcher has to exert a gentle force. Attaching a shoelace to the launcher can help us adjust the force. In Chapter 3, students come to understand that an object starts to move in the direction of the force exerted on it. A key evidence source in this chapter happens after students have investigated making a ball move different directions by changing the direction of the force, when the students then use images from the book, Building with Forces, to visualize making objects move in different directions. At the end of Chapter 3, students are able to explain that to get the pinball moving in the direction we want, either left or right, we must exert a force on the pinball in the direction that we want it to move. In Chapter 4, the lessons lead students to figure out that moving objects can change direction because of a force from a moving object or a still object. A key evidence source in this chapter is when students investigate how to make a ball change directions, and then they engage in the embodied forces routine to practice changing directions. By the end of Chapter 4, students understand that making a moving pinball change direction requires another force to act on it, either from a moving object or from a still object in its path. Chapter 5 focuses on using what students have learned to create a pinball machine that lets them control the way a pinball moves. They learn that engineers construct solutions to do specific things they want them to do. Students write to explain what they know about forces in the How to Play Pinball mini book, and they share and explain their student box models in a box model showcase. By the end of Chapter 5, students can more independently construct a solution to a problem by planning and constructing solutions based on what they've learned, then testing, evaluating, and revising their solution to better meet design goals. As the unit is completed in Chapter 6, students explore where there are forces around us. They collect evidence from a school forces tour and from reading the text, A Busy Day in Pushville. These applications of science ideas to the world around them reinforce the idea that there are strong and gentle forces in different directions all around us. We know a force has been exerted on an object whenever that object starts moving, changes direction, or stops moving. I hope you're feeling excited to get started teaching this unit. In addition to the resources on the Amplify platform, check out the at-home videos for pushes and pulls to help you teach the unit remotely. At-home unit resources will be added on the program hub December 19th. You can use any combination of these resources to engage your students in figuring out about forces in motion. Please feel free to contact me, Patty Works, with any questions or for assistance. I hope this has been helpful. Have a great day.